In the realm of cybersecurity, cross-site scripting, XSS, is a term that frequently surfaces. It's a kind of security vulnerability that can be found in web applications, enabling attackers to inject malicious scripts into web pages viewed by other users. Consider a scenario where you have a straightforward website constructed using only HTML and CSS. When a user visits this site, their browser interprets the HTML and CSS, and that's what they see on their screen. However, most contemporary websites also have dynamic elements. They might, for instance, extract data from a database or request user input to perform specific actions. Visualize this. You might see a form on a website where a user can submit information. The application then sends this information to another page via the URL. This other page takes the URL, parses the information in it, and uses it to populate an HTML field on the page. This effectively allows the user to modify the page. Now let's put on our developer hats for a moment. Suppose we have direct access to modify the code on this page. We might decide to add a script to this page to enhance its functionality. While best practices would have us add the script in the header or the footer of the page, technically the script can be added anywhere on the page. This means that under the right circumstances, an attacker could exploit this to send a script payload via this vulnerable input and then modify the application to do something it wasn't intended to do. This is where cross-site scripting, or XSS, comes into play. XSS is a type of injection attack where malicious scripts are injected into trusted websites and executed by the visitor's browser. Essentially, an attacker finds a way to exploit a simple, supposedly safe website to send malicious code to one or more users. This malicious code is generally in the form of browser-sized scripts, which are simple enough to be created by anyone with internet access. The attacker finds a way to take their malicious code and infect the HTML document without causing the web server itself to be infected. Instead, it uses the server as a vector to present malicious content back to the user. This can happen instantly, in what's called a reflected attack, or it can be delayed through storage and retrieval in what's called a stored or persisted attack. Cross-site scripting attacks are possible when an application uses input from a user within the output it generates without properly validating or encoding that data. Modern browsers are getting smarter and smarter, and they now include many defenses to prevent successful XSS attacks. However, these browser security controls don't prevent all XSS attacks, and while they're not as common as they used to be, they're still found in the real world and are one of the most commonly attempted attacks on applications. Successful exploitation of XSS can do a lot of damage. If an attacker is able to inject malicious scripts into a web application, the browser may end up believing that the script comes from a trusted source, and it will let that script access all kinds of information. This can lead to credential theft, unauthorized payments, user redirection to fake websites, and more. In addition to the information we've already discussed, an attacker could also register and send a user's keystrokes to their own server by adding what's called an event listener, potentially recording sensitive information like passwords and credit card numbers. As we wrap up this video, I want to let you know that in our upcoming video, we will delve into the three main types of XSS attacks, how they operate, the impact they can have on your applications, and how they can be exploited. So stay tuned for that. And before you go, don't forget to subscribe to our channel for more insightful content. Your support helps us continue to produce informative videos like this one. Thank you for watching, and we'll see you in the next video.